Hey everyone, welcome back to the channel. In today's video, we are diving into one of the most powerful memory management features in modern C++, smart pointers. If you have ever used new and delete in C++, you know how easy it is to forget freeing memory, which causes memory leaks. That's exactly why smart pointers were introduced in C++11. They automatically manage memory for you. By the end of this video, you will learn what smart pointers are, why we use them instead of row pointers, the three main types: unique pointer, shared pointer, and weak pointer, how to use them in real examples, and we'll wrap up with a short mini project showing automatic memory management in action. A smart pointer is an object that acts like a normal pointer, but with automatic memory management. When the smart pointer goes out of scope, it automatically deletes the object it points to. So you don't need to manually write delete pointer. This avoids memory leaks and dangling pointers. To use smart pointers, we include #include memory. Let's understand unique pointer with this program here. A unique pointer owns the object exclusively. No other pointer can own that object. To create a unique pointer, we write unique pointer and then the type and give a name to it. After that, we write make unique the data type, and inside the parenthesis we write the value. Unique pointer cannot be copied. So if we try to write unique pointer the data type int p2 equal to p1 will result in error, but we can transfer ownership using move function. After this, p1 no longer owns the memory. So in the terminal we will get value star p1, which is 100. After moving p2 becomes star p2 with the line number 10, we transferred the ownership, right? So here we will get 100, and then the program will print p1 is now null as p1 no longer owns the memory. Let's see if we get exactly that. And we got that. Now let's understand shared pointer. A shared pointer allows multiple pointers to share ownership of the same object. The object is deleted only when all shared pointer owners are gone. So here we share the ownership, and with the reset function, one owner is released. Use count function here counts the number of owner, which in this case are 2, and after the reset the owner becomes 1, and we will have after p2 reset use count 1. The object will be destroyed automatically when the last owner, that is p1, goes out of the scope. Let me create one more program, and with that we are going to understand weak pointer. A weak pointer is used to break circular references, a situation where two shared pointers point to each other, preventing deletion. It does not increase the reference count. In the line number 7, we created a weak reference, and here we counted them. This if-else loop checks if the object still exists. With the reset function, we destroyed the shared pointer. Again, with the if-else loop, we are checking if the object still exists. So earlier the count was 1 and then the value as 50. After destroying it, we got object expired. So with all the examples covered, we now understand unique, shared, and weak pointers. Now we will create a mini project smart pointer in action, which demonstrates automatic destruction of objects. We'll write our headers, iOS stream, memory using namespace std, and then create a class student, and inside the public members we will declare a variable name of string data type, then create a constructor and a destructor. Inside the main we will create our pointers. Let's get started. With this line here, we created a shared pointer. Let's share the ownership. After these curly braces, the shared pointers S1 and S2 goes out of the scope. So with S1 we created student Alice, and then we got 2 using useCount function. Notice how the destructor was automatically called when both the shared pointers went out of the scope. No delete needed, and the program ended. So we learned smart pointers prevent memory leaks and the types of pointers. Great job! You've just learned one of the most important C++ modern topic, smart pointers. They make your programs safer, cleaner, and error-free when dealing with dynamic memory. In the next video, we'll explore namespaces and inline functions in C++. If you found this video helpful, give it a like, comment your favorite use case of smart pointers, and don't forget to subscribe for the next episode. Thanks for watching. See you in the next one.